As you can see from the title, today's lesson is about scientific notation. This is a very practical lesson that we'll be doing today because you're going to be using scientific notation frequently now in, of course, science. The other thing I've noted is on your calculators, several of you have actually been getting scientific notation, and it's been rather confusing for you. So I promise you, if you listen today and pay attention, you'll understand this quite a bit better, and you'll be able to figure out what your calculators are doing and how to interpret the numbers. I want you to note on this slide, we have a number written in scientific notation. So that is 9.77 times 10 to the 22nd power. If it sounded like I just gave you a multiplication problem, you are right. Scientific notation is a number written as a multiplication problem. Just a couple of specifics about this, though. First of all, in scientific notation, the first factor can only have one digit in front of the decimal point, and the second factor is always a power of 10. I think, of course, the best way to learn how to do this is to do a couple of examples, right? So we're going to start with an example that has a positive power, and then in the second example, we'll do one with a negative power, right? So first of all, just remember that when you're multiplying a number by 10, you can just add 1 0. When you're multiplying by 100, you can just add 2 zeros, right? So the same is true here. We look at it in terms of moving decimal points. So, of course, also if you're multiplying something by 10, you can move the decimal point one place to the right, right? Well, we're going to use that same reasoning. Since we have a positive exponent here, 9, we can just solve this by moving the decimal point 9 places to the right. Okay, well, note actually that I can move it 2 places to the right, but then I'm going to have to add enough zeros to get to the 9. So my final answer here is going to be 312, and then my 7 zeros, which will get me up to 9 places that I've moved the decimal point. So that's 4, 5, 6, 7 zeros. Now I'm just going to put my commas in so I can read this number carefully. Right, so that's thousands, millions, billions. So this number is 3,120,000,000. That's the same as 3.12 times 10 to the 9th power. Negative exponents are actually just really small numbers. Remember when we were doing our lesson on negative exponents, I kept saying over and over, a negative exponent is not a negative number, it's a fraction. Right, so really this is dividing. So remember that 10 to the negative 5th power is really the same as 1 over 10 to the 5th. Right, so when we're multiplying 3.12 by 1 over 10 to the 5th, technically it's dividing. Right, so that actually just means moving the decimal point to the left. Right, so you want to move it left 5 places instead of right. So if we moved it back 1, it would be right here in front of the 3. So we'd really need to have 4 zeros in front of it to move it back 5. Right, so I'm going to write it this with a 0 first, and then 4 zeros, 2, 3, 4, 3, 1, 2. So then the number 0.00000312 is the same as 3.12 times 10 to the negative 5th power. On this page, you'll see that we're doing the reverse. We're going to take standard notation this time and write it in scientific notation, right? First thing I always try to do when I'm actually doing this particular direction is figure out if I'm going to have a positive exponent or a negative exponent. It's easy to figure that out. If it's a large number like this one in example 1, it's going to be a positive exponent. If it's a really small number, like this one in example 2, it's going to be a negative exponent. Right? So by large, I mean it has to be over 1, and by small, it has to be less than 1. All right, so next step then is to write this in its correct form with 1 digit in front of the decimal point. Right? So I'm going to write this one as 1.528, and then it will be times 10 to some sort of power. because remember, scientific notation is a multiplication problem. So now I'm just going to figure out how many places I would have between the decimal point and the end of the number. So I'm going back to the original number, and I'm just going to count the spaces. This is where your 3 times table comes in very handy, because we've got 3, 6, 9, and then one more, so it's 10. So the correct exponent is 10. So this number is 1.528 times 10 to the 10th power in scientific notation. The second one will be very similar. I'm going to actually start by putting the decimal point in the correct place. In this case, it's 4.53, always one digit in front of the decimal. And then I'm just going to count the number of spaces between where the decimal point should be and this one in this number. So I'm just going to do this one by counting back. So 1, 2, 3, 4, 5, 6, 7. So it was 7 hops. That's a way to think about it. So this is going to be times 10. And remember, it's a small number, so 10 to the negative 7th. There, we just did it. Okay, so here's your chance to try. So what I'd like you to do is pause the recording, copy these, try them. Then when you're finished, just pipe back in again and we'll work them out together. Okay, so the first one is going to be 417. I have now moved my decimal point 2 places, so I need one more. So the correct answer for number 1 is 4,170. Now looking at number 2, since you've got this negative here, you need to be thinking, oh, a small number, so I need to be moving my decimal point to the left. So since I need to move it back 6, I need to have 5 zeros in front of that 3. This right here gives me 1. So I need 5 more to make 6. All right, so here we go. So 1, 2, 3, 4, 5, and then here's my 3, 4, 1, 9. All right, so there's your answer right there for number 2. For number 3, of course, you're going to start by writing this in its appropriate form. So 4.121553. Note you get all of those digits. By the way, those are called significant digits. We'll talk later about that, but that's just a little bit of information for you for later. All right, and then I'm going to actually count. So 3, 6, 9, 10 times 10 to the 10th. This one, of course, is a very small number, so it must be something with a negative exponent. Right, so we'll start again by putting everything in the correct place. 9.17 times 10. I'm going to put my negative in right now so I don't forget. All right, and then I'm going to count. 1 jump, 2, 3, 4, 5. So 10 to the negative 5th. And there you have it. I want you to note here that we've got a problem that really uses scientific notation. And for now, basically, I just want to take you through the process here. What I want you to do in terms of solving problems with scientific notation is change the numbers to standard form first, then do the math, and then change them back to scientific notation, right? As time goes on, we're actually going to learn how to work in scientific notation without changing it to standard. But for now, if you would change it to standard first, do the math, and then back to scientific, I think that would work the best. All right, nice job, and I hope you have a better understanding of scientific notation.